Hi, I'm Keith Barry from Review.com. Today we're doing some tests on washing machines for washerdryerinfo.com. Right now this Whirlpool is finishing up one of our test cycles, and I thought I'd just take a little time to show you exactly what goes into a test cycle. We try to simulate stains, and we also simulate the weight of an actual load of laundry. So we have over here we have pillowcases, sheets, towels that we load into an 8-pound load that we put into every single wash. Inside of that, we test two things: stain removal, and we also test mechanical action, which is clothes wear. Stain removal is possible thanks to these kind of creepy strips that are pre-stained, and the stains that are on them include pig's blood, red wine, cocoa. We have oil, and we also have some carbon on there as well. So this is what it looks like before it goes in. Each one of these sells for about $25, and they're imported from Germany. And this right here is what they end up looking like after a wash. We use a photospectrometer to find out exactly how close these got to white. And we use a standardized detergent for every single one of our loads, and that's able to tell us about how well a washer is able to get stains out of clothes. We also have these mechanical action strips. Let me get one here which is new. So these are cloth strips. This is what it looks like before it goes into a wash. And once it's done, depending upon how rigorous the wash cycle is, it can end up looking like this, and it could end up looking like this. This is after a normal cycle, and what we do is we count the number of frayed pieces of fabric on here. So if you see right here, this only has a couple of frays right inside there. But if you look at this one right here, this cycle obviously did a lot more damage to the fabric. I mean, we've got 8, 12, 16, frayed right there just on this little subsection alone. So this shows you just how much wear and tear that your clothes will go through when they go through the dryer. So in addition to that, we do some other tests, and I'll also tell you about those. These are regulation test shirts. All right, so I actually have to add some, so what we're doing here is we're doing a debris test that shows, let's say you play on a friendly softball team and you slid into second and you got a lot of dirt in your jeans. What this test shows is how well it'll get that dirt out. So this right here is a filter that we've hooked up the drain hose on the washing machine to, and whatever dirt that's in here that gets washed out will get caught inside of this little this sieve right inside there. We'll weigh that, compare it to the 25 grams we originally put in, and see how well it did. So I'm going to go over to the scale now and weigh some dirt. All right. We've got our 25 grams of dirt, and now it's time to throw it in the washer. All right, so we're going to sprinkle this in here. We're going to do the heavy-duty cycle. I'm going to turn on this drum light here so you can see inside. And we're going to fill it up. So something I hear a lot of customers start to complain about is that their washers don't fill all the way to the top. And back when washers used to not have windows on them and they weren't as water and energy efficient, people just assumed that water came all the way up to the top. And that's not the case, and nor does it need to be the case. What really gets the cleaning done is a decent load of water, which all the clothes can soak in, and then a wash plate at the bottom, which will move those clothes around and make sure that they all get wet. In a front-loading washing machine, it uses gravity to actually flip the clothes over on top of each other to make sure that they all get that moisture inside of them. But clothes don't need to be soaked, and the tub doesn't need to be filled all the way up to the top. And that's how one of these will run you, a modern washing machine will run you probably $30 to $60 a year to run, as opposed to an older washing machine which would run a lot more than that, and also saves a lot of water in the process.